Good morning, children. Last time we had discussed about physical changes and chemical changes. Now, chemical changes, a change in which a new substance is formed. A chemical change is observed if a gas is evolved, state is changed, or color is changed, or there is involvement of heat. If such things are happening, then a change is said to be a chemical change. And a chemical change results in a chemical reaction. A chemical reaction can be written in different forms. First, descriptive. When a reaction is written in form of sentence. Example, magnesium burns in air to form magnesium oxide. So this is said to be descriptive. So when we write in sentence a reaction, a chemical change taking place, then it is said to be descriptive. Next is word equation. If we write the reaction in words and in the equation form, then it is said to be word equation. For word equation, two things are very important. One is a reactant, that is the substance that is reacting, right? And the other is product, the substance that is formed as a result of a reaction. Now, reactants are always written on left-hand side, while products are always written on right-hand side. And the reactant gets converted into product. It is indicated by a conversion sign of an arrow, which is placed between these two, and the head of arrow always points towards the product. So the above reaction, that magnesium burns in air to form magnesium oxide, can be written in word magnesium plus oxygen forming magnesium oxide. The product formed is magnesium oxide. The third way of writing a chemical reaction is chemical equation. We represent a chemical equation in terms of symbols and formula. So when any reaction is represented in terms of symbols and formulae, then it is said to be a chemical equation. Now, magnesium reacts with oxygen to form magnesium oxide. Now, the symbol of magnesium is Mg, while that of oxygen is O. But when oxygen is present in the gas state, then it exists as diatomic molecule, so we write O2. Not only oxygen when it is in the air, hydrogen also when it is in the air, we write as H2. Right? Chlorine also we write when it's in the gas state, we write as Cl2. So oxygen out here is O2 and it forms the product magnesium oxide. Now, how do we get this formula? You've done it in class 9. That's why I told you to revise what you had done in class 9, how to write symbols and formula. Now, a equation. When you write a chemical equation, it's very important to see whether that equation is balanced or not, right? Now, how do we find out whether an equation is balanced or not? What we have to do is we'll see the total number of atoms towards the reactant side as well as the total number of atoms of each element towards the right hand side. If we see in this equation, magnesium towards the left hand side is 2, right? And right hand side also it is 2, because 2 in front of this formula, this 2 now is for magnesium also, and this 2 is for oxygen also, right? Whenever a number or coefficient is written in front of the formula, then it belongs to all those elements that are present in that molecular formula, right? So magnesium is 2, here also magnesium is 2, here oxygen is 2, and here also oxygen is 2. So every element that are present on right hand side, the number of atoms of these elements and the number of atoms of these the elements that are present on right hand side and left hand side, they are equal. So if they are equal, then it is said to be a balanced equation. But if the number of atoms of each element on left and right are not equal, then the equation is said to be an unbalanced chemical equation or a skeletal equation. Here, if you see this one, magnesium On left hand side 1, but on the right hand side also it's 1. Fine, it is equal, but oxygen here it's 2, and on the right hand side it's 1. So this is not a balanced chemical equation. It is said to be a unbalanced chemical equation. Am I clear? Okay. Next, why do we need to balance a chemical equation? What's the need of balancing it? So this is done to justify the law of conservation of mass, which you had done it in class 9, which states that mass can neither be created nor it can be destroyed in a chemical reaction. That means whatever matter was before the reaction, the amount of matter, the number of atoms that were before the reaction, the same number of atoms should be after the reaction or when the product is formed. That means the total mass of the reactant should always be equal to the total mass of product. So to justify the law of conservation of mass, it is necessary to balance a chemical equation, right? Now to balance a chemical equation, we have a method that is known as hit and trial method. Hit and trial method indicates hit and trial. That means you need to keep on trying, right? You need to practice a lot, right? To balance a chemical equation. You keep on changing the numbers, the coefficient in front of the symbols and the formula. Then till you get the equal number of atoms of each element towards the left hand side and right hand side. Now, how we balance a chemical equation, I have given certain example in the other videos. You go through those videos, and after seeing those videos, I'll give you some questions also for practice. Please do those questions. Of course, in your register you can do it, or in your old notebook, wherever you want to do it. Practice those questions. Try to write the chemical equation, a balanced chemical equation, and then the answers we'll discuss in the next class. You don't have to upload that work. It's just for your practice. Am I clear with it? So please see those videos, and after that do the assignment work. Thank you and have a nice day.